Today we will see about the examples based on twist factor, and if time permits, we'll see about the examples based on irregularity of the yarn. So you already know the concept of this twist factor, right? So we know that what is the function of twist, the yarn. So twist provides the strength to the yarn. Twist provides strength to the yarn. Right? The main function of twist staple fiber yarn is to give the coherence to the yarn, right? When we apply the twist to the fiber, right? When we apply twist to the fiber, what it does, it gives the binding to the fiber. It gives the binding to the fiber. So the strength will get improved. So the strength will get improved in the yarn. Right? So because of the coherence, strength of the material will get improved. That is the main function of the twist. The yarn. We see the yarn structure. You can see here. In yarn, how the fiber moves during the twisting operation. Everyone know that the fibers, drafted fibers, are coming out of the front drafting roller, and at the bottom side, there will be a spindle, and on the spindle we are having a bobbin, right? And we are used to wind the yarn over the bobbin. How the twist will get inserted, that phenomenon we already know. As your fibers are gripped by the pair of front roller, and at the bottom side where the bobbin is placed over the spindle, and spindle is revolving with a very high speed, right? So your one end is gripped and other end is revolving. It means what? The fibers inside the structure will start to twist. So it will follow a helical path. Because of this, it will follow a helical path. We know it like this, and it will settle down in between. Suppose this is a structure of yarn. Fiber is following the helical path. Depends on the tension level onto the fiber and fineness of the fiber. It will get settled down. Suppose this much is the length of the fiber, right? So it starts from the surface, goes to the center, again it tries to go to the surface, but it will settle somewhere in between. There might be another fiber which is starting its journey from this point, and again it will follow and it may settle here. There might be another fiber which starts its journey from this point and it may be settled down here. Likewise. In short, our fiber follows a helical path during the twisting operation. Right. So all these part you have already studied in spinning. Right. Here our interest is to find out the equation for the twist factor. Right. So now suppose if I open this yarn, so if I cut it from the center, from the center, and if I open it, right, it will follow this shape, right, rectangular shape, right? And if I take the fiber, right, then we can able to find out this angle. Here you can see, right, this angle we can able to find out. Now we'll see the equation. We'll find out this angle. How you will find out this angle? This yarn, suppose for example, this yarn is having the length L. This yarn is having the length L. How you will find out this angle? If I want to find out tan alpha, how you will find out tan alpha? So this length is L. So your tan alpha is
pi d upon L.
Right. Pi d upon L. Your tan alpha is pi d upon L. Okay. So your tan alpha is pi d upon L. So we know that 1 upon L is the turns per centimeter. 1 upon L is the turns per centimeter. Here pi d, if we separate, the remaining will be 1. So 1 upon L will be the turns per centimeter. So that we can able to write that tan alpha is directly proportional. Tan alpha is directly proportional to the diameter into turns per centimeter. Diameter into turns per centimeter. We have removed this equality sign. We have removed this equality sign along with the constant, so that in mathematics we have to take this directly proportional sign, right? So tan alpha is directly proportional to diameter into turns per centimeter. But we also know that our diameter of the yarn is proportional to the square root of the linear density. Diameter of the yarn is also proportional to the square root of the density, right? So we can modify the formula. Tan alpha is directly proportional to the square root of density, that is d, square root of density into turns per centimeter. This is remaining turns per centimeter. So the formula will get modified like this. Tan alpha is directly proportional to the square root of x into turns per centimeter. Now again, if we want to remove this sign, and if I want a equality sign here, you have to consider a constant. So we have considered a constant as k. So k is equal to square root of linear density into turns per centimeter. So these are mathematical rules, just we are applying here. So k is equal to square root of linear density into turns per centimeter. So this will be your formula for twist factor. K is equal to square root of x into turns per centimeter. If the k is lesser, your material will be softer. If the k is higher, your twist is hard, means material is hard. So depends on k. Higher the k, harder is the twist. Lower the k, softer is the twist. So you just remember this formula in textile mathematics. We are not going to deal with this equation derivation, right? So we are using this formula, right? So you can write this formula: k is equal to square root of linear density into turns per centimeter. That is the formula for twist factor. Sorry. Okay. Write down this numerical. Everyone write down this numerical. Okay, return the example. So what is the example here? A 25 tex yarn is spun with a twist factor of 30. How many turns per centimeter are there in this yarn? Simple. So very simple example. What they have given here? What is the given data? Given data here. Linear density they have given, that is 25 tex, right? And twist factor. Twist factor means K they have given 30. K they have given 30. And they ask for the turns per centimeter. They ask for the turns per centimeter. Now you use the formula for twist factor. That is K is equal to square root of tex, right, into turns per centimeter, and find out the turns per centimeter and tell me the answer. कितना था आंसर?
6 tons per centimeter.
6 tons per centimeter आता. So here K is how much? K is 30. 30 divided by square root of tex is 25. So square root of 25 means 5. So 6. So answer is 6 tons per centimeter. 6 tons per centimeter. So this is very simple example actually. Okay. Here is the solution. Okay, now write down another numerical. On a ring frame, the yarn delivery speed is 10 meters per minute and the spindle speed is 10,300 rpm. Calculate the twist inserted into the yarn when the winding on circumference is 10 centimeter. Does the twist inserted have the same value in winding on at a larger circumference? You write down this numerical, then we'll see about this. Okay, everyone written the numerical?
Yes, sir.
Okay. Now see what they have told here. On a ring frame, the yarn delivery speed is 10 meters per minute and the spindle speed is 10,300 RPM. Right. So they asked to calculate the twist inserted into the yarn when the winding on circumference is 10 centimeter. Right. First of all, we'll see this part because this question is asked in two parts. In another part, they asked does the twist inserted have the same value in winding on at a larger circumference? That we'll see later on. First, we'll try to solve this first part of this example. So they ask for the calculating the twist. So we know that the formula for twist by considering the example. In the example, what they have given the spindle speed. They have given the spindle speed, right? And also they have given the delivery speed, right? They have given the delivery speed. So the general formula for the twist per inch we know. Can anybody able to answer me? Twist per inch formula. You have already seen it in third year. TPI.
Spindle speed divided by delivery speed.
Spindle speed divided by delivery speed. सही है. Spindle speed divided by delivery speed. Right? So spindle speed is in RPM obviously and delivery speed in meters per minute. Meters per minute. So here we have to calculate this twist inserted. Twist inserted. This one you have to calculate. Right? Twist you have to calculate. So as here the package circumference, that is winding on circumference, is in centimeter, we will calculate the twist per centimeter. We will calculate the twist per centimeter. So our formula will get modified accordingly. Twist per centimeter is equal to spindle RPM divided by delivery speed in centimeter per minute. Centimeter per minute. Right? So here we have to calculate the twist per centimeter, that is twist inserted into the yarn. Now can I take here spindle RPM 10,300 RPM? Delivery speed I can calculate. Delivery speed it is 10 meters per minute. So 10 meters per minute, 10 into 100. So it will be centimeter per minute. So I can take this 10 into 100 centimeter per minute. Can I take here spindle's RPM as 10,300 RPM? Can I take here 10,300 divided by 10 into 100? So the answer is no. Answer is no. We cannot take this 10,300 RPM. We cannot take this 10,300 RPM. So why we are not able to take this 10,300? There is a basic theoretical concept. So just few minutes before I told you your material is coming from the front roller and it is going to wind onto the bobbin. So during winding, during the twist insertion, first of all it will follow this path, circular path around the bobbin, and in the meantime then twist will start to flow. Twist will start to flow. So this revolution we have to remove. Whatever the revolution it is making, yarn is making around the bobbin, right? So this is the bobbin chase. Sorry, this is the bobbin chase. We can say from here material is going to wind like this, right? So in short, your yarn is making revolution around this bobbin, around this bobbin. So obviously certain spindle revolutions will go in that. certain spindle revolutions will get waste in order to wind this yarn over the surface, and then twist flow will be there. It means what? We have to remove the winding revolutions. We have to remove the winding revolutions from this total number of revolutions made by the spindle in a minute. Right. Now, how you will calculate the winding on revolutions then? How you will calculate the winding on revolutions? Simple. In a minute, we are delivering 100 meters. We are delivering 100 meters. Means 100 into, sorry. In a minute, we are delivering 10 meters. So, in short, we are delivering 10 into 100 centimeter. If I divide this value by the package circumference, what is the circumference?
10.
10 centimeter.
10 into pi.
Here it has been given directly circumference, so not need to take a pi. By including pi, they have given the value. Winding on circumference, they directly told you the value 10 centimeter. Understood? So we are not taking pi here. If you want to find out the circumference, then you have to take the pi d. They have not given here diameter. They have given directly the circumference. Understood the difference? Am I correct or not? Somebody told pi, that's why I am explaining. Okay. So here we'll take the circumference. So whatever the value will come, that value is nothing but the RPM required for winding on revolution. The RPM required for winding on revolution. Am I audible now?
Yes, sir.
Okay. So here, instead of taking 10,300, first of all we will find out winding on revolution, and then we'll deduct this winding on revolution from the spindle RPM. Then we'll get the actual RPM required to insert the twist. Actual RPM required to insert the twist. Okay. So this thing you might have not studied in third year. You have only studied that we'll take the spindle speed. So somebody told you spindle speed is 15,000, right? You will take directly this 15,000, but you will get the wrong answer. That's why you will find difference between calculated value and actually when you test the twist, when you calculate the twist in the laboratory. So you have to consider this also, winding on revolution. So what we'll do now, sorry. Okay. So here, first of all, we will calculate winding on revolutions. Winding on revolutions. Now, how to find out? We'll see. So for that, first of all, we have to find out length delivered per minute. It will be 10 into 100 centimeter per minute. So this is very simple thing. That's why I'm taking directly. Length delivered per minute is equal to 10 into 100 centimeter per minute. Right? Your package circumference is how much? 10 centimeter. Your package circumference is 10 centimeter. So therefore, winding revolutions is equal to, as we have discussed earlier, we'll take here length delivered divided by
Yes, sir.
circumference. Right? What will be the answer?
100.
100. So in short, we required 100 winding on revolutions, 100 winding revolutions. Right. So what I will do now, I will deduct this from the actual spindle revolutions. Actual spindle revolutions are 10,300. So what we can write here, spindle revolutions used for inserting twist is equal to 10,300 minus 100. It will be 10,200 RPM. It will be 10,200 RPM. Okay. Now this value we can take as a spindle RPM. Now this value we can take as a spindle RPM. Now we will take here, as I don't have space, so I am writing here, twist per centimeter is equal to spindle RPM into front roller delivery, that is delivery, right, in centimeter per minute. So here spindle RPM is 10,200 divided by delivery. How much it is? How much it is? Tell me.
10 into
10 into 100.
10, 100.
Because we have to take it into the centimeter per minute. So 10 into 100. So when you do this calculation, this 0 will go, this 0 will go. So how much is the answer? आंसर बताओ. Tell me the answer, don't message.
10.2.
10.2. So the twist per centimeter is 10.2. Twist per centimeter is 10.2. Now here we have covered our first part up to this. How much calculate the twist inserted. So we have calculated the twist inserted. It is 10.2 centimeter. It is 10.2 centimeter. Now another part. Does the twist inserted have the same value in winding on at a larger circumference? If we increase the circumference of the package, is the twist inserted will be same? That is the answer. That is the question. Have you got the question? If we increase the circumference, package circumference, does the twist inserted is the same? We'll find out this. Now suppose initially it was 10 centimeter. Now if I increase the circumference as 20 centimeter, so from 10 centimeter if I increase to 20 centimeter, then I will calculate the things. Again I will calculate the length delivery per minute. It will be same, 10 into 100 centimeter per minute. Here now package circumference will be 20 instead of 10, right? Again I will calculate the winding revolutions. Winding revolutions will be 10 into 100 divided by 20. Now it is 20, right? When we do this calculation, right, 2 5 here the answer will come as 50, right? 50 RPM. So when we increase the circumference, the winding revolutions required will be 50 RPM. Winding revolutions will be required 50 RPM. Now I will deduct this 10,300 minus 50. So answer will come 10,250. 10,250 RPM. So in the case of larger circumference, say for example 20 centimeter, the winding spindle revolutions required to insert the twist is 10,250. So I will use this value and again I will calculate the twist per centimeter. It will be 10,250 divided by 20. So you just, sorry, how much it is? Sorry. $10,250 divided by 10 into 100. How much is the answer?
सर 20 into 100 लगेगा.
20 into 100.
5.2.
20 क्यों लगेगा रे?
5.12.
20 क्यों लगेगा?
सर डिलीवरी का स्पीड कैसे चेंज होगा सर?
वही तो कंफ्यूज हो गया मैं. 10 ही रहेगा वो. डिलीवरी का स्पीड कैसे चेंज होगा? ये डिलीवरी स्पीड है ना ये. व्हाट इज दिस? डिलीवरी स्पीड. डिलीवरी स्पीड इज 10 मीटर्स पर मिनट. वो क्यों चेंज होगा? नहीं होगा चेंज. 10 ही लेना है वहाँ पे. 10 ही लेना.
10.25.
हाँ, 10.25 is the answer. 10.25 is the answer. So, have you got any difference here? Have you got any difference here? Does the twist inserted have the same value?
थोड़ा ग्रेटर हो गया ना सर?
Yes, it is slightly increasing. It is slightly increasing, right? It is not the same. If it come exactly 10.2, then it will be same. Because this is turns per centimeter. When you calculate into turns per inch, it will increase. When you calculate into turns per meter, again it will increase. So the twist inserted is changed, but that change is negligible. That is your conclusion. So in this way, we have to solve this numerical. So this question is asked for GATE 2003, and you don't believe that this question is asked only for 2 marks. Right? Because the concept is very simple. Concept of the numerical is very simple. One simple formula we have to use here. E per centimeter is equal to RPM by delivery. बस यही आपको यूज करना है यहाँ पे. खाली इस RPM का सोचना था तो आप मन में भी सोच सकते हो. कितना है इसका डिलीवरी? 10 है. 10 into 100 हो जाएगा. ये 10,300 कैसे आएगा? ये डिलीवरी इतना है. 10 into 100 या रफ भी कर सकते हो आप. डिवाइड बाय सर्कमफ्रेंस कितना है? 10 सेंटीमीटर है. सर्कमफ्रेंस कितना है? 10 सेंटीमीटर है. ये करूँगा तो मेरा आंसर आता है 100. इसका मतलब इसका 10,200 है. तो डायरेक्टली मैं ले लूँगा यहाँ पे 10,200 डिवाइडेड बाय 10 into 100 करूँगा रफ में. जब ये कर दूंगा तो आंसर मेरा आता है 10.2. सिमिलरली अगेन आई विल थिंक फॉर द हायर. आई विल टेक हायर. 20 लूँगा, 30 लूँगा, 40 लूँगा, जो भी मेरे मन में आ गया, क्योंकि उधर ऑप्शंस रहेंगे. ऑप्शन के हिसाब से आपको समझ में आएगा वहाँ पे. सो अगेन आई विल कैलकुलेट हियर एंड 10 into 100 I will get 10.25. So the answer will be either A, B or C or D, जो भी रहेगा गेट में. So 2 मार्क के लिए आता है. दिस इज द लॉजिक. सो आपको अगर गेट को अप्लाई करना है तो हर एक कॉन्सेप्ट आपको अच्छी तरीके से मालूम होना चाहिए और सब कैलकुलेशन मन में होना चाहिए. हाँ, जहाँ पे कैलकुलेशन की जरूरत है वहाँ पे रफ पे आप लिख सकते हो विदाउट द यूज ऑफ कैलकुलेटर. उस टाइप के ही क्वेश्चन आते हैं. ऐसे नहीं आते कि आपको लंबे चौड़े डेरिवेशंस रहेंगे, फिर आपने सॉल्व किया, फिर एक पर्टिकुलर आंसर आ गया, फिर आपको 2 मार्क मिले. ऐसा नहीं रहता कभी. अब लॉजिकल क्वेश्चन रहते हैं. फॉर दैट यू शुड बी क्लियर विद द लॉजिक. सो हियर we have completed this numerical. In our university examination, this question comes for 7 marks. Sometimes I seen this question has come for 11 marks or 14 marks. I don't know why this question is asked for 14 marks, but some of the university paper it has been asked for 14 marks. Okay. So here actually I have solved this numerical. Okay. Now there is a question which is in continuation with the previous one. Right? There is a question which is in continuation with the previous one. If the linear density of the yarn in the last example where 16 takes, what twist factor would have been used? Right? If the linear density of the yarn in the last example where 16 takes, what twist factor will use? So what is the formula for twist factor? Again, twist factor is equal to square root of takes into turns per centimeter. So in last example, turns per centimeter is 10.2. We have calculated 10.2, right? And linear density, what they told, it is 16. So it will be 16. So what twist factor you will use? So we'll calculate the twist factor. This is very simple example again. Right, it is 4, 10.2. So how much is the answer? 8, 40.8. Okay. So in this way you have to solve the numerical. Everyone solve this numerical? थोड़ा फास्ट करो, अभी एग्जांपल्स बहुत है, बहुत सिलेबस कवर करना है. सबने निकाला क्या?
Yes, sir.
Okay. So everyone got the answer 40.8. Everyone got the answer 40.8.
Yes, sir.
Okay. So we'll move ahead. Write down this example. Everyone write down this example very fast. Okay. Everyone written this example? Hello? Please try to reply fast. Everyone written this example?
Yes, sir.
Okay. So what is the example? A spinning firm uses a twist factor K expressed as K is equal to turns per inch divided by square root of English count, cotton English count. Right. Now, initially they are using this expression, but now they want to change over to the text system. Right. Initially they were using the English system. Now they want to change it to the text system, and they use the twist factor T. Right. In case of English count, initially they are using the twist factor as K, Now they want to change it to the text system, and they have used they wish to use the twist factor T based on turns per meter, obviously, because text, if we know the definition of text, we take a weight in gram for 1000 meters of material, right? So you have to take here turns per meter instead of turns per inch, okay. And linear density in text instead of cotton count, linear density in text instead of cotton count. So these much changes they want to make, right? So obviously what changes they made, instead of K they have taken T, instead of turns per inch they are taking turns per meter, and instead of count, English count, they are taking text. Now they ask to derive an expression, for T in terms of K, right? And also they have given 1 meter is equal to 39.4 inch and x is equal to 590.5 square divided by count, English count. That we know actually, that we have discussed already while calculating the or solving the yarn diameter related numericals. Now simple thing, we need a relation between, actually what they ask the relation between T and K. They ask the relation between T and K, right? They ask the relation between T and K. So that we will find the relation between T and K. Here we are going to find. Okay. So what we know, sorry, just hold. We have given that K is equal to turns per inch divided by, I will write here count, cotton count. Now therefore K is equal to, now this turns per inch we have to convert it into turns per meter. How you will convert it? Tell me. This turns per inch you have to convert it into turns per meter. This turns per inch you have to convert into the turns per meter. How you will convert it? Because we have to take here turns per meter instead of turns per inch. So should I take here directly turns per meter, divided by, so we'll think about this later on. So convert it into turns per meter. You just convert it into turns per meter. Turns per inch you have to convert it into turns per meter. How will convert?
Divided by 39.4 inch.
Very simple. Turns per meter, if you want, obviously you have to divide it by 39.4. You have to divide it by 39.4. Very simple logic. Why you people facing problem, I don't know. Right? So divided by 39.4. Divide it by 39.4. So turns per meter divided by 39.4. Now at the denominator, so instead of count, we have to take the text. We have to take the text. So what is text here? They have given the text. Text is 590.5 divided by count. So I will write here 590.5 divided by text. Right? Because this is count here, cotton count. So it will go here and text will come here. right? So 590.5 divided by X. Now I will solve this, I will get the relation. If I solve this, I will get the relation. So here I will solve. Therefore, K is equal to turns per meter divided by 39.4 divided by, can I write like this, 590.5 divided by X. I can write this. This is mathematical rule. So therefore, if I further solve this, what I will get, K is equal to turns per meter. This division will go at the denominator, 39.4. So this will be already at the denominator, square root of 590.5, and this division will go at the upper side as per the mathematical rules. So square root of X. Square root of X. So what is this here? What is this? Turns per meter into root X. What is this? Tell me. Turns
Twist
per
factor.
meter. Yes, twist factor. It is twist factor. So what they ask here, in text system, I will use twist factor as T. I will use twist factor as T. So I can write here T. I can write here T. So therefore K is equal to T upon 39.4 into square root of 590.5. Square root of 590.5. You solve this and tell me the answer of this 39.4 into square root of 590.5. Do it fast. You calculate this.
Nine 957.4.
957.4. सबका आता है? Everyone got the same answer?
Yes, sir.
Let me check. I will calculate it on my calculator. Okay, 957.4. 957.4. 42. Okay. So we get this answer, 957.4. So I will convert for the T. Therefore T is equal to this 957 will go this side. 957.4 into K. So this is the relation. This is the relation. So this will be the answer that you have to find here. So in this way you have to solve this numerical. Okay, you can make a screenshot and later on you can do it on your notebook. So here we have completed the numericals based on twist factor. In next lecture, we'll see about the numericals based on irregularity of the material, irregularity of the textile material.